Okay, so good afternoon, everyone. Thank you for sticking to us till now. And we're going to have a talk titled as Optimizing Recommendations on Wattpad Home. And we have two wonderful guests for today, and I will go over their bio. First of all, we have Gayathri Srinivasan. She is an accomplished AI product manager at Wattpad, specializing in personalized ranking and recommendations. With over 7 years of diverse product management experience across various industries, including startups, scale-ups, and enterprises, she brings a wealth of knowledge and expertise to her role. Second of all, we have Abhimanyu. He is a data scientist at Wattpad, and an online social storytelling platform where he leads and develops a recommender system that contents recommendations. He holds a master's degree in big data analysis from Trent University with a specialization in natural language processing. He has developed and implemented robust AI solutions throughout his career across diverse domains, including internet-scale platforms, metal and mining, oil and gas, and e-commerce. So without any further ado, please help me by giving these two wonderful guests a warm round of applause.
Hello. Okay, there we go. Thank you so much, everyone, for coming out here to listen to us talk about optimizing recommendations on the Wattpad homepage. So we'll be quickly going over a little bit about Wattpad today, for those of you who are not familiar with the platform, and then get to the topic of the day today, which is personalized recommendations. We'll also talk about some of the areas of opportunities that we identified at Wattpad and some of the solutions that were explored in order to address those areas of opportunities and the results that we saw from the experiment that we ran. Okay, so diving into a little bit about Wattpad. For those of you who don't know, Wattpad is a leading web novel platform. It's part of a larger company called Webtoon Entertainment. Like an easy way to think about this is it's like a YouTube, but for books. So it's a lot of UGC content. Beyond just the app, we also have a book publishing house where we can buy physical books. And we also have studios that helps produce big short movies. You might recognize a few, like After or Kissing Booth, that's also available on Netflix. All of the work that we do is rooted in our vision to entertain and connect the world through stories. So before I dive into personalized recommendations as the main topic, I want to talk a little bit about why we chose the homepage as the place to optimize the recommendations. So there's two main reasons we did this. The first is that home is the primary point of content discovery for a user. That's where they enter, whenever they log in, that's the place where they enter. And the second is, even though we have recommendations in all the other areas of the app, the homepage houses over a third of the algorithms and the personalized recommendations. And so it makes it a really powerful place to enable content discovery. But why focus on personalization specifically? Again, there's two main reasons. The first, and this is applicable to any recommender systems, is that our recommendations on home has multiple stakeholder groups. So, like talking about Wattpad, there are three primary stakeholder groups. One is the readers. These are folks like you and I who want to find personalized, relevant stories or books to read. The others are writers or creators who write these books and they want to be discovered and they want to grow their content. And the last is the business who wants to meet their revenue and subscription goals through our original stories called Wattpad Originals. As you can imagine, personalization means vastly different things for each of these groups. And so that makes it a really interesting challenge for us to solve. The second is purely the scale of Wattpad. We have over 55 million stories and 170 million users. You can imagine that it must be really difficult for a user to actually sift through all of these stories to find a great story for them. So the power of personalization is really make or break for a platform like Wattpad, because we have a very short period of time to give the user what they want. And we all know we are in this kind of attention economy right now. So we really need to build recommendations that win. But when you think about the recommendations market, it's highly competitive and it's highly saturated. So not only are we fighting to hold the user's attention in our own platform, but you're also fighting to hold their attention against multiple platforms. Do they spend time on Wattpad or Netflix or Spotify? So we need to make sure that when you build recommendations, it has a defensible moat. So how do we do that? So I'll go over like 3 strategies, but I'm sure there are more. So the first one is, and arguably the most important one, is you need to understand your users in a lot of detail. Every click, every read, every add to library, you need to know when they're doing it and why they're doing it. And understanding the why is so critical because this helps you uncover the user's need. And when you uncover the user's need, it gives you the context for the recommendation that you want to build. So as a user, I might be going to Wattpad on a weekday versus a weekend to do 2 completely different things to satisfy 2 completely different needs. So it's really key to get that. The second one is using design as a strategy to make your recommendations stand out. When Pinterest launched their infinite scroll in the homepage for recommendations, it was a game changer. But today, if you think about recommendations, pretty much all recommendations look the same. Whether it's content or media or even e-commerce, there's a standard-ish template that we are all used to and we all expect. Not saying that you cannot push the envelope still when it comes to design, but design is no longer a standalone strategy that is not easily copyable. So you need to build something that is not, like I'm not saying folks can't copy other things, but it needs to be done in a way where it's not easy to do it. And that brings me to the third point, which is relying on your technical core competency as a differentiator. So what I mean by this is that thinking about what is the data that only we have and the capability that only we have. So what is it that is unique to you and your company, and how can you build a moat using that? A good example, a really famous one, is how Netflix breaks down their recommendations of videos into frame-by-frame sections, and then they do pattern matching between what the same user watched or multiple users watched, and they also use this to personalize a thumbnail for a user. Now, sure, someone else can copy that, but to build the ecosystem around this and to lift and shift that is not an easy task. So when it comes to Wattpad, our moat or our technical core competency is really the amount of text data that we have access to and the context of that text data in relation to how the user interacts with it. All right, so now that we understand how to build great, not just good recommendations, let's move on to the next part, which is the areas of opportunities. So we've identified 2 main areas of opportunities in Wattpad, and I'll go over them one by one. The first one is actually a 2-part problem. And it's very simple, and I think this applies to all recommendations. All users want relevant and personalized recommendations. But personalization, by definition, works better when a user has built more equity on the platform. And what I mean by that is if you watch more, if you add more playlists, you're adding more data and you're building equity. And so it's easier, I would say, to personalize for a user who has data built on the platform, as opposed to a user who's cold start or who has just joined the platform. But the expectation of that user doesn't change. They still want relevant, personalized recommendations. So how do we do that? That's a challenge we want to explore. Secondly, personalization, like I said earlier, is quite a competitive and saturated market. So we need to go beyond the surface level metadata, and because that's table stakes at this point, and we need to provide recommendations that really resonate with the user. The second part I want to talk about is users want fresh and diverse recommendations. So you can think about personalization and diversity almost being at 2 ends of the same spectrum, because the more personalized you get, let's say for a stakeholder, like in our case, the reader, we might tend to drive them into rabbit holes. But so how do we give them a personalized experience while also making sure that the recommendations are fresh and diverse and meeting other stakeholder needs? So this is another challenge that we explored. And Abby will be going over some of the solutions and the experiment that we ran. So let me just pass it on to him.
Now that we understand the key user problems, let's explore how we map these problems to technical objectives and build solutions for them. But first, let's set the stage by briefly reviewing the high-level components of the recommender workflow used on the homepage. So the workflow you see on the screen is a simplified version of the actual recommendation system used at that time. It follows a common pattern used in large-scale recommender system, typically consisting of 2 to 3 key steps, where the output of one is fed into the next one. As you can see in the workflow, it begins with candidate generation, where the input is a corpus of millions of stories available on Wattpad. In this step, we have different algorithms that select relevant stories for a user based on different features, like user metadata, content metadata, their interaction history on the platform, and so on. The output of this step is a pool of relevant stories coming from different candidate generation algorithms. In the ranking step, we rank these stories primarily based on engagement metrics. Finally, this ranked pool is transformed into a 2D page using the row builder module. To address the problems Gayathri just described, we conducted numerous experiments over the years, modifying different components of this workflow. In the rest of the presentation, I'll discuss an end-to-end example of one of our top-performing experiments. We'll look at the modifications we made to the different component of this workflow, namely the data layer, the candidate generation layer, and the ranking layer. Let's talk about the data layer first. User research and analysis of generated recommendations indicated a need to improve our content understanding to generate more relevant recommendations, as at that time, the content metadata we had was fairly limited and not detailed enough. So we decided to create several new domain-specific datasets in order to improve our content understanding. And this involved extracting key metadata features from our story corpus. One such dataset was TENS, which was used for multi-class emotion analysis from long-form narratives in English. As you can see from the table on the screen, it contained passages of text with a label indicating an emotion user might feel when reading that passage. It had around 9,700 passages, averaging 86 words each, and was collected from Wattpad and other online sources. Now you may wonder, why did we choose emotion as a content metadata signal? Understanding emotions is crucial, as character dialogues and narratives in storytelling carry strong emotions. Memorable stories are the ones that resonate with the user on an emotional level. And I think this is true beyond just stories, as the last conversation or movie you enjoyed likely invoked some emotion. So emotion as a content metadata is a powerful signal for us. So once we have this data set ready, what did we do to label it? We used Plutchik's wheel of emotion, which consists of 8 primary emotions, like anger, sadness, joy, fear, etc. And more complex emotions can be formed by combining 2 basic emotions. So for example, this emotion of love can be thought of as a combination of emotions like joy and trust. This wheel also captures the intensity of an emotion. Again, going back to the example of joy, the emotion of joy can vary between serenity and ecstasy. The later iterations of this dataset included longer passages and multiple labels per passage indicating the different emotions a user might feel while reading that passage. Similar to emotions, we identified several other critical metadata features and created datasets focusing on those specific features. We created several classification models by fine-tuning pre-trained transformer models on these datasets. In summary, using these new datasets and machine learning models trained on them, we labeled our story corpus with richer metadata features. These features were then exposed to our users in forms of UI UX changes, helping them make more informed decisions. They were also used in our recommendation models to generate more relevant recommendations. Talking about recommendation models, let's have a look at the candidate generation step. For candidate generation, we had 3 key goals. Number 1, we wanted our recommendation models to work for all users, and especially cold start users or users who have very little to no interaction data. Second, we wanted to use our recommendation models for multiple use cases, which in our case means recommending not just stories, but different entities like readers, writers, all from the same model. Also, we wanted our recommendation models to generate diverse content. Since our existing models of the time missed some of these requirements, we decided to create a new model that can complement our existing models and fulfill these certain use cases. After experimenting with different architectures, we chose graph-based models for several reasons. Number 1, Wattpad, in essence, is a social network. So different entities like readers, writers, stories can be naturally expressed using a graph. Second, graph-based models offer better interpretability. Next, these models complemented our existing models of the time like matrix factorization and two-tower models in terms of how they generate recommendations, performing better in cases where the existing models underperformed, especially for cold start users. Talking about cold start users, these models have inductive capabilities. So you can generate recommendations for previously unseen users or entirely new sets of users. And lastly, in contrast to approaches like matrix factorization, which captures signals from direct connection of a user to generate recommendations, these models can not only look at direct but indirect connections of a user to generate recommendations, thereby extracting more complex relationships from the data. Before we dive deep into the new architecture we developed at Wattpad, let's briefly understand how graph-based models are used in the industry to generate recommendations. Consider the graph that you see on your screen as a social network of users on Wattpad. Different nodes represent different users, and an edge between two nodes represents some sort of connection. And the node properties represents their interest. So we can see that node Henry is connected to Alistair, and node Henry is interested in art, comics, and games. Now, a common task in graph-based models is link prediction. So let's say you want to recommend some connections to Henry. Bill and Terry can be possible candidates. So graph-based models assign a link score to these potential missing links. And the higher the score, the more likely the recommendation. But how do they assign this score? So they do this via something called as message passing. So they convert the node representations into node embeddings. Let's say you want to get the node representation for node Henry. As there are different layers in the graph neural networks, each layer looks at different neighbor features. So the first layer might look at the direct neighbors of Henry and aggregate features from them, as shown in yellow. The second layer might look at the neighbors of Henry and aggregate features from them, shown in orange. And we do this for a certain number of time until we get the final representation for node Henry. We repeat the whole process for the other candidate, Bill, and we get the node representation of Bill. Once we have the node embeddings or representation for both of these nodes, we use that to calculate the link score. Now, for a small graph like this, you can literally use all the other nodes in the graph to get the node representation of Henry. But in real-world use cases, where graphs have millions of nodes and edges, this becomes unscalable. So what do? Popular graph-based approaches like GraphSage do something like this. Let's say you want to get the node representation for this central node. First, they sample some neighbors for that given node. Then they'll only aggregate the features from these sample neighbors to get the representation of the node. And that representation can be used for the downstream task like link prediction, node classification, or something else. When we started working on this, existing graph-based approaches of the time had some challenges. Like GraphSage doesn't naturally support heterogeneous graph, which in our case means that we cannot have multiple edge types. And since we wanted a model that can be used for multiple use cases, this was a problem. So we cannot have an edge type for a reader-to-reader connection, a reader-to-writer connection, etc. Also, there is a problem of how can we smartly combine all of these features from the neighbor to get the node representation. For this problem, graph attention models handle this through attention. But they suffer with scalability for large and dense graphs. Due to these concerns, we decided to create our own architecture. The proposed architecture you see on the screen is related to GraphSage and graph attention models, which, as we saw in the previous slide, reduces neighbor representation from fixed size samples. In our case, for smartly combining the neighbor features, instead of uniformly sampling neighbors at each depth of connections, we propose a single reduction of multi-step neighbors. For sampling the neighbors effectively, we use multi-step transition probabilities, allowing the model to select the most informative neighbors of a particular node. For allowing different edge types, each edge is represented as a vector that the model learns during training, thereby allowing the model to understand the importance of different edge types. We also use a attention mechanism to understand the importance of different sampled neighbors, as shown in the middle of the chart. Finally, once you have all this information, we aggregate the features from the sample neighbors by taking into account their learned importance as well as their edge type to get the feature representation of a node. Let's briefly understand this with the help of an example. Let's say you want to get the node representation for Vi. First, using multi-step transition probabilities, you will sample the neighbors of Vi, and these can be direct or indirect neighbors, as shown here. Then, for each neighbor, you will calculate their attention weights or their importance. And finally, using the edge type information and their learned importance, you combine the features for all of the neighbors that are sampled to get the representation of Vi. Once we had this model, we used the features we extracted from the datasets we created in step 1 as node features in our graph-based model. This allowed us to extract more complex relationships from the data, and also benchmarking showed that introducing this graph-based model in our candidate generation step improved our recommendation quality, and especially for cold start users. Now that we had a better candidate pool, let's look at the changes we made to the ranking step. As Wattpad as a platform matured, we introduced several new types of content and classes of stories. This, in turn, generated a need for our home recommender system to evolve to one that must balance different objectives simultaneously, like engagement, content diversity, marketing objectives, revenue, etc. But our ranking model at that time was ranking the candidates solely based on engagement metrics, and that no longer aligned with our goals. As you can see, that the content discovery process on home page is a multi-stakeholder problem. And the entire ecosystem works properly when each stakeholder is happy. So our objective was to optimize such objectives of different stakeholders jointly. And as Gayathri mentioned in her section of the presentation, and you can see it also from the graph, that objectives of different stakeholders can be sometimes conflicting and are usually diverse. So there is no one feasible solution that maximizes all of these objectives simultaneously. So we were looking for Pareto optimality. Having this in mind, we decided to create a ranker that can meet these different goals to meet the need of our stakeholders. For our solution, we chose bandit algorithms, in particular contextual bandits. In our bandit setting, we provide a contextual vector to our recommendation policy, incorporating different features like user, their location, time of the day, etc., to generate more relevant recommendations. In our bandit setting, we use a multi-objective based Thompson sampling bandit. The policy finds the most optimal ranking of the candidate actions. In our setting, the candidate actions are the different candidate generation algorithms in our candidate generation step. Since we have multiple objectives, we assign one reward per objective. Now, there can be some objectives that are subjective, like the satisfaction reward, which intends to provide a reward based on how much a user liked a particular piece of content. In those scenarios, we add dynamicity to our rewards by co-clustering our users and their content based on certain engagement metrics. Finally, we scalarize all of these rewards to get the final ranking for a user candidate generation algorithm pair. By adding this new ranker in our workflow, we were able to optimize the multiple objectives of our stakeholders simultaneously. The combined effect of all of these changes in our workflow resulted in an improvement in our metrics. So let's have a look at the results. For this experiment, we had two key metrics dimensions. First was engagement, to address the first user problem of recommending highly personalized and relevant content to all user segments. And second metric dimension was content diversity, to address the second user problem of recommending fresh and diverse content to our users. Adding the graph-based model resulted in an improvement of 17% in our engagement metric and 3% in our content diversity metric, while the multi-objective ranker increased our engagement by 2% and content diversity by 11%. You can use this mic. You can use this.
Thank you. All right. So we hope you are able to take away a few of the key points that we've laid out here. The first one is really understanding your user need. So please understand every single thing that the user does. This will give you the context you need to build your recommendations, and therefore you'll be focusing on the right problems to solve. The second one is to identify and rely on your technical core competency while using design best practices alongside that in order to build a defensible moat around your recommendations.
From a data science perspective, I want to leave you with two key recommendations. Number one is on measuring performance. For your AI system and model, measure the performance by different user segments and also dissect the performance by different components of your AI system in order to identify any weak links or underperforming user segments. Second, as they say in machine learning, there is no free lunch. So understanding your data and user behavior on your platform is crucial to identify the right model type, as usually that leads to significant improvements.
Awesome. Thank you so much, everyone, for coming out here and listening to us. I also want to give a shout out to the folks at Wattpad who couldn't be here to represent all the work that we did together with them. And Abhi and I are really passionate about this, so feel free to discuss the topic with us anytime.
Hello. My question is, how are in the graph that you had, kind of between different types of users, how were like what was your definition of how they were connected? Like what did the link actually represent between, like, for example, two readers? Was it a similar kind of preference in terms of like content? Was it? I was just trying to understand that a bit.
Yeah, that's a good question. So in our case, that can represent multiple things, even for the same entity. So it could be that the two readers read the same story, or maybe they liked the same story. So it's on a high level, it's the same. It's an interaction that they did on a particular entity together. It could also be like maybe they follow the same writer or something like that. Yeah.
So multiple representations are for the same. Okay.
Exactly.
And I guess my follow-up there, sorry, is for cold start users, how is that addressed when you have a graph representation like this? Because there's no connections when they enter the site for the first time. So was there like a different was it like the closest kind of based on kind of what they clicked on once? I was just trying to understand how you address that.
Yep. So there can be multiple things that we can do. So in our case, that could mean that, let's say if you and me, we both join the platform and we both are from Canada, or let's say maybe the same city, then that's a link. And that can link you with users who have more interactions. So let's say if I join from Canada and multiple other users who have lots of interactions from Canada, we can use those signals to recommend some stories,
right, okay,
maybe that are popular in Canada.
Cool, thanks.
Hi guys. So very cool presentation. One thing I was wondering about was how can you guys tell if like a user is like just clicking on a story and like not reading it, or maybe they could be like really engaged in it and just like not moving anything? Like, is there like a way you can like tell how engaged they are? Like, I don't know, based on how they scroll, or I don't know, like, because if they just click on a link, like there must be something more to it, right?
Yeah, can I take this one?
Yeah.
No, 100%. I think before we can start doing any sort of recommendations or personalization or machine learning items, your data analytics layer needs to be really strong. So you need to have events firing for every single like design area of the app. So let's take this example of identifying how engaged a user is, right? So when they click, how quickly are they clicking into a story details and bouncing? What is their completion rate? How many parts do they read? And like, so we have multiple stages at which we like kind of measure the level of engagement within a story that ranges from a click bounce to a click to 1-part read, to 5 parts read, to 20 to 50% completion, and like entire story completion rate. So I think like before we can start doing anything meaningful, if we don't have the analytics layer in place, it's going to just be very difficult, and you will have a lot of noise.
I see. And is that something that you guys are able to do manually, like the rules, or is that something you guys have to like train for as well, like the analytics side of
No,
like
the eventing
like the
we-
policy basically? Like, do you have to like? Can you just figure it out like by like?
Yeah, so there are two things. So first is we have to collaborate with product to come up with certain rules and what things we want to track, and user research. What's a good measure of like engagement? And yeah, apart from that, on the technical side, there are like multiple tools that we use to get the data based on those rules.
Thank you.